the title of this problem is Cannon shooting downhill. Now, you have probably seen the regular projectile problem in which you have a projectile fired at an angle theta with initial speed v0, and then it flies and hits the ground at distance L. Now, this problem is probably solved in class. You have seen it and you have understood it. Now, of course, we're going to solve something more difficult. Now, in our problem, again, you're going to have a projectile fired at theta above the horizontal with initial speed v0. But this time, the ground is not straight. It's downhill, like so. And it's downhill at an angle phi. Now, I drew it exaggerated. Normally, we're thinking of small angles, not 90 degrees down. So what happens is the projectile flies and hits the ground at some distance, again, L, from the shooting point horizontally. So the question has two parts. A, find L, given v0 and theta. And of course, phi. B, I want to find theta for maximum range, which means at what angle should I be shooting my cannon so that the cannonball will reach a maximum distance L from the point where I shot it from. Now, for the easy problem, you might want to go back and check that for phi equals 0. When the ground is flat, maximum range happens when you shoot at 45 degrees. What happens now?
Pi over 4.
Pi over 2? No, pi over 4. Right. I meant 45 degrees. I said 90 degrees. What I think is right. Now, so how do we go about this? First, I need to place my coordinate system. As usual and as convenient, I will put it at the point where the cannon shoots the cannonball will be, so I'll define my x and y right there. So as usual for projectile motion, I'm going to ignore air drag. So x and y motions are going to be independent of each other. The cannonball is going to move at constant speed in the horizontal direction. And in the vertical direction, it's going to start with a certain speed, and it's going to accelerate downwards with the acceleration of gravity. So if we put that into equation form, I'm saying the horizontal motion will just happen at Vx, so which is just V0 times cosine theta. And in the vertical direction, the speed will be, initially it will be Vy, and then with time, we'll do minus gt, it will accelerate downwards. So if I write the equations for x and y, for x I'm going to get V0 cosine theta times t, and for y, well, plus a constant, call that C1, and for y I will get Vy, no, well, I'll say V0 sine theta times t minus 1/2 gt squared plus another constant c2. Now, c1 and c2, if you look at the equations, those are just the x position and the y position of the cannonball at t equals 0. Since I placed my coordinate system with the origin exactly where motion starts, both of these constants are in fact 0. So I can erase them. Now, what do I do next? I need to find out where, at what point will this motion hit the ground. So I need to find the relation of this. Well, normally horizontally, if it was horizontal, I would have just said when y equals 0, it would have hit the ground. Not so in this case, because it doesn't happen when y equals 0. When does it happen is the question. That would be the equation of my ground level in this case, which is going downhill. So it's not, I can't say that's just 0. What's the equation of this is the question. So if you just think of a right triangle here with the angle phi there, this is y and, well, I can call this, well, y ground, and I can call this x ground. So y ground is just what? X ground times tangent phi?
With a negative sign.
If I define it down, it's with a plus sign, but it's better to define it as probably, since my y is always up, so okay. All right, then with a negative sign.
Your phi is positive, then
If my phi is positive,
you need a minus.
then I need a minus sign here. So I define phi to be positive when the slope is going down. So this is the correct equation. So then what? Now I need to solve these two equations simultaneously. So when do these two things intersect is the question. When exactly the x and y are the same. So when y of the ground is equal to y of the bullet and x of the ground is equal to x of the bullet, these are going to be intersecting. Right? So essentially, then to solve this together, this must hold for the bullet, for the cannonball as well. So the cannonball will hit the ground when it obeys the equation of the ground. So it means y equals minus x tangent phi for the cannonball as well. Now, how many equations, how many unknowns do I have? I have x, y, and t, and I have three equations. I have this one, and I have y equals x minus x tangent phi. Three equations, three unknowns. I should be able to do this, right? In fact, right now, physics is pretty much over. The rest is about mathematics, whether we can get this right. To clarify, okay, now, yg and xg were the variables of the ground's coordinates, and x and y were the position of the cannonball. These will be equal only upon impact on a single point. You're not supposed to take this to mean that these are functionally equal. These are equal at a single point where the impact of the cannonball with the ground happens. So when does it happen is, so I can start by getting the time out of this equation. So the impact time will be x over v0 cosine theta. And I can plug that time directly to the equation of y here, out of which I will get y equals v0 sine theta times x over v0 cosine theta minus 1/2 g t squared will give me x squared over v0 squared cos squared theta. So that gave me, in fact, this gives me the parabola equation for the flight of the cannonball. And exactly when that intersects with this equation, which came from the equation of the ground level, then we will have impact. So instead of y, I can substitute minus x tangent phi, and I get an equation in x alone, which is, so I get minus 1/2 g 1 over v0 squared cos squared theta times x squared plus, let me see, v0's cancel. I get tangent theta plus tangent phi. Did I get it right? Yes, good. Now, it's a second-degree equation, but luckily I don't have a constant term. One of the solutions is x equals 0. Now, this shouldn't be surprising, because at t equals 0, I already do know that I do intersect with the ground. I'm looking for the other root. So I can, without fear, cancel out one of the x's, saying the x equals 0 root is useless. I already knew that. So the solution remains for the intersection point. The impact happens when? So it comes out positive. It should. Tangent theta plus tangent phi times v0 cos squared theta, v0 squared cos squared theta over g with a 2. Good. And this is x at impact, which I defined to be L to start with. Right? So, well, then if I want y impact, that's simple from here. This is just minus x impact times tangent phi. Not very interesting. You just get a minus sign and a tangent phi. So now, is this correct? Now, what can I look for? Does it make sense? First, you got a g in the denominator. That makes sense. More gravity means you fall faster, so it should go. It shouldn't go that far. You have v0 squared. Well, the faster you throw it, the further it will go. Cos squared theta, well, what happens if phi is 0? For phi equals 0, this should reduce to the usual flat ground problem. You get tangent theta times cosine squared theta, which is sine theta cosine theta, which is sine 2 theta, so it does reduce to the correct thing. So yes, it looks to be correct. Now, the other part of the problem is to solve for theta for maximum range. Now, this is obviously dependent on theta. So how do I find theta for maximum range? Well, I need to take the derivative of L with respect to theta, and then set that equal to 0. That would hopefully be the maximum range. Now, I think I have to erase. So L is 2 tangent theta plus tangent phi times cosine squared theta over, well, V0 squared over G. Now, the LD theta is, well, I can put the 2V0 squared over G at the start. They're not going to change much. So the derivative of tangent theta, now I need to do, is this easier if I do this first? D by d theta of cos squared theta plus tangent phi cos squared theta. I want to take the derivative of this. I did the multiplication first because the whole thing is going to come out simpler. So tangent theta times cosine squared theta is what? Just sine theta cos theta. And here I have cos squared theta, and this is in fact 1/2 of sine 2 theta.
Yes.
Yes. So I'm being evil, but this is a video, so you can go back and see what I'm doing. Right. So this is much easier to take the derivative of. So the actual derivative is, again, 2V0 squared over G times, okay, the derivative of sine 2 theta is 2 cosine 2 theta. So it cancels with the 1/2. I get cosine 2 theta. And the derivative over here is tangent phi. It's independent of theta. So the derivative of cos squared theta would be 2 cos theta times minus sine theta. So this switches to a minus sign. And again, 2 cos theta sine theta is sine 2 theta. Now, as you can see, things are working out nicely. It will not always be the case. The trigonometry may turn out that you can't actually solve it. In this case, we're lucky. It's a special case. So here, I'm going to set this equal to 0 to find the maximum. Now, so this is not going to be 0, obviously. Whatever is going to happen is going to happen here. So eventually, the idea is cos 2 theta minus tangent phi sine 2 theta equals 0. So I get what? Tangent phi equals cosine 2 theta over sine 2 theta. So I get tangent phi times tangent theta equals 1.
2 theta.
Sorry, yes. Fixing what was here? Cosine 2 theta over sine 2 theta. So I got tangent 2 theta times tangent phi is 1. So how do we solve that?
Cotangent 2 theta is equal to tangent phi.
Right. Cotangent 2 theta equals tangent phi. We're turning things around. Then what?
Cotangent 2 theta is tangent pi over 2 minus 2 theta.
Right. The thing is, if I can get these to the same trigonometric function, then it becomes very easy all of a sudden. If I had a cosine on one side, then I would be in trouble here. But I can say cotangent of 2 theta is tangent of pi over 2 minus phi. No.
2 theta.
Cotangent of 2 theta.
Tangent pi over 2 minus 2 phi. Pi over 2 minus 2 theta.
Well, I did it the other way around. Okay, I'll do it your way. So you're saying tangent of phi,
Cotangent 2 phi equals
cotangent 2 theta I have,
2 theta
equals,
tangent.
I already have a tangent. I want
No,
cotangent.
I'm with cotangent 2 theta.
Oh, okay, okay.
Tangent
Tangent pi over 2 minus
2 theta.
2 theta. So you're just telling me the trigonometric identity, cotangent identity.
Tangent phi.
Now that's equal to tangent phi. What does this mean? We have two angles whose tangents are the same.
In the same quadrant.
Well, if we are sure they're in the same quadrant, they're both positive and less than pi over 2. So if both theta and phi are between 0 and pi over 2, then we can say they're equal. So the solution becomes phi equals pi over 2 minus 2 theta. So
Theta equals
theta equals pi over 2
4.
pi over 4 minus phi over 2. Yay! So the thing is, after a certain point where you took the derivative, set it equal to 0, the rest depends heavily on how much trigonometry you can do. Normally, if you're solving something along these lines, like another problem we considered solving here was a similar problem where the ground went downhill, but you fired the projectile from an initial height h. If you try that, this equation becomes horrible. You just can't get it out. So in this case, it's simple enough that it will spit it out if you do the right trigonometry, but it may not always happen. What happens then? Well, normally you end up with an equation like this, and then you have to solve it numerically. You're not always this lucky, but we happen to be. So our final answer, I'll repeat here, it's pi over 4 minus phi over 2. Now, whenever you find an answer like this, you need to check whether it makes sense. Now, our one checkpoint was here. Initially, I wrote this before solving the problem. I said, for phi equals 0, theta must be pi over 4. Check. Yes, when you said phi equals 0, theta equals to pi over 4. As phi gets larger, okay, your theta gets smaller. which means instead of shooting more vertically to gain more distance, you can shoot more horizontally, get more horizontal speed, because the ground itself is already going down, so it will go farther that way. And when phi reaches pi over 2, which means it's going directly down, so you never hit the ground, so then theta becomes 0, so you just shoot horizontally because it flies forever. Kind of makes sense. End of problem.